Yesterday, we started talking about phasors and how to convert from time domain to phasor domain. And I told you that for any resistor, if you would like to represent it in phasor domain, it will be the same R. For any inductor, if you would like to represent it, the inductor is represented in phasor domain by j omega L. What's omega? 2 pi f. F is the frequency. And the capacitor is represented by negative j 1 over omega c. And j omega L or negative j 1 over omega c or r, all of them have units of ohm. That's why I'm going to deal with j omega L or negative j 1 over omega c as if it is similar to the resistance. But the only difference is the resistance is real element, but j omega L is imaginary. Negative j1 over omega c is imaginary. This is the only difference. And any voltage source or any current source is represented as a function of sine or cosine. And then I will write it as magnitude and angle. Then I can solve the problem. Imagine I have a problem like this one. Here he is telling me, for this circuit, could you please calculate the total impedance between A and B? Actually, this problem is similar to what we solved it before at the beginning of this semester. These two are connected in, yes, 5 and J20 are connected in here. That's why I'm going to add them. And 2 and negative J10. So I will say 2 and negative J10 will be equal to 2 minus J10. And the overall of this guy with this guy in, yes, parallel. Then the overall of this guy with all of those, yes. So what am I going to do here is 5 plus J20 is connected in parallel with 2 minus J10. And the overall of this is connected, in series with 4 plus J5 minus J2. This is the total. So this will be equal to 5 plus J20 multiplied by 2 minus J10 divided by 5 plus J20 plus 2 minus J10. And the result of this guy will be added to 4 plus J5 minus 2 will be 3. So the problem right now is a mathematical problem. How to solve that problem for finding Z total? I will try to do one of two things. Convert those to P polar or multiply without conversion and see what's going on. If you would like to multiply, you will multiply this guy by this guy and this guy by this guy, then this by this and this by this. If you try to do that, you will have here 2 plus 5 is 7 plus J10 and 5 times 2 is equal to 10 and then plus 5 times negative J10 is equal to negative J50, then J20 times 2 is equal to J40, then J20 times negative J10 is equal to J square 100 multiplied by negative, but J square is giving me negative sign, so negative times negative will be positive. At the end, I will have plus 200. Am I right? Then I will try to add up real to real and imaginary with imaginary. So 10 plus 200 will be equal to 210. And then I'll have negative J10 divided by 7 plus J10, this guy plus 4 plus J3. I'm not solving right now. I'm not using electric circuits. I'm using mathematical explanations to simplify that. The first step was depending on using the concept of electric circuits. Now I would like to simplify this guy. So you have one of two options. Convert this guy to bipolar and convert this guy to bipolar and divide them. Magnitude divided by the magnitude and subtract the angle, or multiply this guy and this guy by the conjugate of this. Whichever is more easier for you, you can use it. I'm not going to force you to do something you don't like. Whichever you are seeing more easier for you, you can do it. But I have two different ways. Let us solve by using the conjugate. So if you try to use the conjugate, and I think using the conjugate here would be more better, because at the end, I would like this guy to be written as real plus imaginary. Because at the end, I will add it up to this. So I would like to have the same format. So 200 negative J10 divided by 7 plus J10, I will multiply by the conjugate of the denominator. So 7 negative J10 over 7 negative J10. Who is not understanding that part? Okay, plus 4 plus J3. This guy will be equal to, generally speaking, if you're multiplying number by its conjugate, it will be equal to the real square plus the imaginary square. Am I right? So this guy will be 7 squared plus 10 squared. Then I will distribute this time this, and this time this, then this time this, and this time this. If you try to do that, you will have 7 times 210, and you will have 210 times negative J10, so negative J10 multiplied by 210, and then you will have negative J10 multiplied by 7, so I will have negative J70, and then negative J times negative J will be plus J squared, which is negative, and then 10 times 10 will be 100. If you try to simplify this guy, oh, I forgot to add, plus 4 plus J3. If you try to simplify this guy will be equal to 1370 negative J 170 divided by 149, this guy plus 4 plus J3. If you try to simplify this guy, divide this by this and this by this, at the end you will have 9.19 minus J 14.56. Don't forget plus 4 plus J3. Then I will add this guy to this guy and this guy to this guy. So you will have here 13.19 minus J 11.56 ohms. Any question for that? I showed you here step by step how to solve problem using complex numbers. And yesterday I did that. Right now I think you are able to solve any problem using complex numbers. It's straightforward. Use the previous methods that we used before, apply them, and then try to simplify your problem based on complex numbers. Let us see one problem which is talking about node voltage methods. So imagine I have this circuit. This guy is 100 angle 0 volts. This guy is 10. This is 5, J10. This is 5, and this is negative J20. And he is telling you here for this problem, use node voltage methods to calculate V1. And he told you that this is V1. Do you still remember node voltage methods? How many nodes do we have? 1. I will say summation the current for that node is equal to 0. Do we know this voltage? It is 100 angle 0. Do we know this voltage? It is 0. Do we know this voltage? It is unknown. This is what I need. So I will say summation the current for that node or around that node is equal to 0. I will write one equation function of V1. But before I start doing that, I have to be sure that this problem is represented in phasor domain, not in time domain. Okay, let me see the voltage. The voltage is represented as 100 angle 0. Is it time domain or phasor domain? It's phasor domain. 5 ohms, time or phasor domain? It doesn't matter because it is a resistor. J10, it's phasors. 5 phasors or time domain, 10 phasors or time domain, negative J20 is phasors. Right now, I don't need to convert from time domain to phasor domain because the problem is given in phasor domain. So if I have a problem like that, and I didn't give you the time domain function, you will solve the problem in phasor domain, and you will not convert from phasor to time domain. Why? Because I don't know the shape of the waveform. Is it function of sine or function of cosine? I don't know. That's why I'll leave it in phasors. But if I gave you this guy, 100 sine omega t plus whatever angle 0, at that time, if you would like to calculate V1, you will solve the problem in phasor domain, but after that, you will convert it to time domain. But right now, I will not do that. I will solve the problem in phasor domain. I'll leave it as it is because you didn't show me the original waveform of the voltage in time domain. You told me 100 angle 0. Is it function of sine or cosine? You didn't tell me. Yes.
How do we know the capacitor doesn't have
The capacitor what?
doesn't have a voltage?
This is steady state. Now, I will say summation the current for that node is equal to 0. Then I'm going to assume that all currents are leaving. So summation I is equal to 0 for node 1. So this current is V1 minus 100 angle 0 divided by this impedance. So V1 minus 100 angle 0. I can write it 100 without angle 0 because angle 0 doesn't make a big difference. So I can write it only 100 if the angle is 0. And 100 could be real and could be magnitude. It could be real parts for the rectangular formatting or the magnitude for the polar formatting. In all cases, the imaginary part is 0 and the angle is 0. This guy minus V1 minus 100 angle 0 divided by 5 plus J10 plus V1, which is this current, divided by 10 plus this current, which is V1 minus 0 over J20 plus 5 minus J20, 5 minus J20. This guy is equal to 0. Now your problem is how to find V1. I will try to simplify the circuit as much as I can, and I'll leave it to you to complete it. But I will show you how to do that. So what do you need? You would like to find V1. It's better to collect everything related to V1 in one side and everything else on another side. So I can take V1 as a common element multiplied by 1 over 5 plus J10 plus 1 over 10 plus 1 over 5 minus J20. Am I right? I try to take this part and this part and this part. What is left? This guy with negative sign. I will move it to the other side, which is 100 over 5 plus J10. Don't ask me why you didn't write the angle, because it is 0. Are you seeing what I did, guys? So I will try to simplify solving that problem as much as I can. You are looking for calculating what? For calculating V1. Okay, so should I add this to this to this by converting from rectangular to polar, or by multiplying by conjugate? But the problem is I have this guy and this guy. And then I have this guy as well. If you try to think a little bit, you don't like to see a rectangular formatting in the denominator, right? So what's your opinion if I multiply the whole equation by 5 plus J10? Both sides, did I make any change? No. I can do that. So multiply both sides by 5 plus J10. If you multiply this guy by 5 plus J10, this term will be equal to 1. So multiply both sides by 5 plus J10. So I will have 1 times 1 plus. This guy will be 5 plus J10 over 10. It could be written like 0.5 plus J, yes, then plus 5 plus J10 over 5 minus J10. This guy is equal to 100. Is it more easier right now? Yes. What I have only is this term. I can multiply both numerator and denominator by the conjugate of 5 minus J20. If you try to do that, you will write V1 times 1.5 plus J1 plus 5 plus J10 over 5 minus J20 multiplied by 5 minus J20 plus J20 divided by 5 plus J20. This guy is equal to 100. Is there any mistake? Are you seeing anything? Any question? Okay. Now, this guy will be V1 times 1.5 plus J1 plus 5 squared plus 20 squared. Then 5 times 5 is 25 plus 5 times J20 will be J100. Then J10 times 5, J50. J times J will be -1. So it will be negative 10 times 20, 200. This guy is equal to 100. then I will have V1 times 1.5 plus J1 plus this along with this will be negative 175, right? Plus J150. Then I have 25 plus 400. This guy is equal to 100. Then this guy will be written as V1 times 1.5 plus, I'm showing you step by step. You don't need to do that in the final exam. I'm showing you step by step because I would like you to know what did I do while I'm solving this problem. But you don't need to show me all of these. Then plus negative 175 plus J150 divided by 425. Then I can rewrite this as V1 times 1.5, this divided by this, minus 175 over 425 as the real part, plus J times 1, and I have here 150 divided by 425. This guy is equal to 100. This guy is real, and this guy is imaginary part. Now I have V1 times real plus J imaginary is equal to 100. V1 is equal to what? 100 over that number. Am I right? And this is the end for the story. You can complete that step. I think it's very easy. Any question for that problem, guys? Okay. Let us talk about the last topic that I would like to cover in our course, which is complex power. Complex or apparent power. We studied before something called power, if you still remember. What is this kind of power that we studied? Do you remember the equation for that power? P was equal to what? Excuse me? V times I, or I squared times R, or V squared over R. Am I right? But this power was the power in which element? It was the power only in the resistor. Because in the previous chapters, we didn't talk about the power in the inductor or the capacitor. We were talking about the power in the resistor, which is equal to I squared times R, or V squared over R, or V times I. Because we didn't deal with inductor or capacitor. And we were calling this power as P. And P means active power. And its unit was watts. Right now, I'm seeing Jx for the inductor, or negative Jx for the capacitor. So we are expecting another power coming from the inductor or the capacitor. Am I right? This power, is it real power or imaginary power? It's imaginary because it's coming from Jx or negative Jx. That's why the power that we have already used before, we are calling it real power, active power. But the power coming from the inductor or the capacitor is called imaginary part of the power. So if I asked you about that power, it is equal to what? Similar to the power in the resistor. So this power is equal to what? It is equal to I squared multiplied by XL. X for the inductor. The magnitude of R. Or I squared, the magnitude of I multiplied by X for the capacitor. But like what you are going to see with me, that power, next term in circuit analysis, I'm going to show you that for finding that power, we are using the root mean square value of the current or the voltage. So if you would like to find the power, you have to find the RMS value of I. What is the RMS value of I or V? If you are talking about sinusoidal waveform, the RMS is equal to the maximum divided by root. Right? So, if you would like to find the reactive power or the imaginary part of the power in the inductor, it's equal to I magnitude square RMS multiplied by X for the inductor. What about for the capacitor? Negative I square multiplied by X for the capacitor. So I can say the total power is equal to summation for, I'm talking about the imaginary part of the power, magnitude of I RMS square multiplied by XL minus XC. Am I right? If XL and XC are connected in series. But why we are calling the power in case of the resistor as active power, and we are calling the power in case of the inductor or the capacitor as reactive power? I'll give you a very simple example. Imagine that we would like to play soccer. We have many students here, 270 students. Imagine I would like to play soccer, and I have many of you, and we have two teams. We have the soccer ball, but we don't have playground. Can we play? No. We need to have a playground to be able to play soccer, right? Imagine we have the playground, we have teams, and we started playing. Benjamin scored, Ashley scored, and whoever is attending today scored. Ali scored. Right now, by the end, there is a team who will win and another team who will lose. But my question right now, the playground is scoring or you are scoring? Who is scoring, guys? You, right? You are scoring, not the playground. So why do we need the playground? To play. So if I asked you to define the playground, what is the playground from your point of view? What is it? Define the playground in a very simple sentence. Yes. The media that I need if I would like to play soccer. Without having that guy, I couldn't play. The playground is not playing, right? Let us go back to electric circuits. Imagine we are talking about fan. And for fan, we are converting electrical energy to mechanical energy. Am I right? If you try to see what is inside the fan, there are some coils. The theory of operation of the fan, like what you are going to study later on if you join electrical engineering, based on we have a magnetic flux. I don't know if you remember the rule that you studied in physics, the three fingers which are perpendicular by using right or left hand rule. If I have a current and I have magnetic flux, then I will have a force. Do you remember that? Yeah. Okay. So this is the theory of operation of the fan. The fan is working based on that. I have a magnetic flux coming from where? Coming from the coils. And I have a current coming from a battery. Then there will be a force. So the magnetic flux is the medium to see the force. If I don't have magnetic flux, am I expecting to see the force?
No.
No. This is what we studied in physics. Am I taking magnetic flux? No. I'm taking mechanical energy, which is force. Coming from what? Coming from the current. So let us talk about, again, players and playgrounds. The magnetic flux is the playground, right? And the players are described by the current. So if you are talking about the power, I have two different types of power. The active power and the reactive power. The active power is I squared times R. This is what you have already defined it. And the reactive power is I squared times summation XL minus XC, which means the active power, which is P, is the real power the players who are scoring. This is what I'm seeing. I have heater, and I'm taking heat from that heater. This is coming from the active power. I have land. There is inside it something happened, but at the end, I'm seeing the light. This is the active that I'm taking. But what about the reactive? It is the magnetic energy inside the machine itself. I'm not taking it, but at the same time, without it, I couldn't be able to have the active power. That's why we are defining the power by two different components. The active power component, which is P, and the reactive power component, which is Q. The active power component is the real power, but the reactive power component is the imaginary power. So the summation of those two, which is real and imaginary, is called the complex power. Are you seeing right now what is the meaning of the complex power? You don't need to understand the whole story, but I prefer to know it. It's better to know what is the meaning physically of active and reactive power. Any question for that, guys? I didn't write the equations, but I'm showing you what is the meaning of this guy and that guy. Any question for active and reactive? So active power is considered at the playground? No, the reactive, it is the media for the active to be appeared, right? So if you would like to define your complex power, S is the complex power, which is the summation of the active and the reactive. S is equal to what? It is equal to the voltage as RMS multiplied by the current as RMS, but the conjugate of the current. And you don't need to know from where you got that equation, because for those of you who will study with me circuit analysis, we will repeat that story again. And I'll derive all of these equations again. And I'll show them for the first chapter from where I got that equation. S is equal to V RMS times I RMS conjugate. And this S is equal to two components, real part, which is P, and imaginary part, which is Q. And the unit for this power, since it is VI, is called volt ampere. This is the unit. It's volt ampere. Now, this has two different components. You told me it has P and the Q. We are calling P as active power or real power. This is P. And we are calling Q as reactive power. or imaginary part of the power. P is equal to what? P, the unit for P is watts. This is the unit. And the unit for Q is volt, ampere reactive. Now, what's P? P actually is equal to the magnitude of V RMS times the magnitude of I RMS times cosine the angle of the voltage minus the angle of the current. This guy is voltage angle, and this guy is current angle. Or you can say P is equal to summation of I RMS squared multiplied by R. But Q actually is equal to V RMS times I RMS multiplied by sine the angle of the voltage minus the angle of the current. Or you can say Q is equal to the magnitude or summation of, generally speaking, summation of magnitude of IRMS squared multiplied by X for the inductor minus summation of IRMS multiplied by X for the capacitor. We are calling this guy at the power factor. So the power factor is described as cosine the angle of the voltage minus the angle of the current. And the power factor is very important thing. I'm going to talk about it next term in circuit analysis. How to improve the power factor and what is the importance of that guy. We will talk about that in more details. But right now, I don't need anything from you except knowing the difference between the active and the reactive power and the power factor. Let us see example which is talking about that story to show you how to use these equations. Any question before start writing the example? Yes.
Is there supposed to be a square on the IRMS?
It is, yeah, I'm sorry, I forgot to write it. Yes, thank you. I square RMS, yes. I said it, but probably I forgot to write it. Any question, guys? Now, let us see this example. If V of t is equal to 100 cosine 1000 t plus 20, and I of t equals 5 cosine 1000 t minus 40. What do you want? Calculate the active power, reactive power, complex power, and the impedance. For solving that problem, I have to find the RMS values. What is the RMS for the voltage? The RMS is equal to what? 100 over root 2. And the angle is 20. What about IRMS? And the angle, but be sure that those two are represented as function of cosine or sine. They should be like that. If one is defined sine, another one cosine, you have to convert one to the other. And you know how to do that. Now, what do you want? You would like to calculate the active power. What is the equation of the active power? P is equal to VI cosine. So I will write here P equals V RMS magnitude times I RMS magnitude times cosine the angle of the voltage minus the angle of the current. So this guy will be equal to V RMS 100 over root 2 times I RMS 5 over root 2 times cosine the angle of the voltage minus the angle of the current. 5 times 100 will be 500 divided by 2 times cosine 60. At the end, it is 125 watts. Any question for that simple equation? He asked me about Q. It's similar to this equation, but instead of cosine, we are using, yes, we are using sine. So V RMS times I RMS times sine phi V minus phi I. This guy will be equal to, similar to the above equation, 100 over root 2 multiplied by 5 over root 2 multiplied by sine 20 minus 40. So this guy, if you try to calculate it, it is 216.5 volt ampere reactive. What else did you ask me about? I asked you about the complex power. So you told me the complex power S is equal to P plus JQ, which is 125 plus J216.5 volt ampere, or S is equal to V RMS times I RMS conjugate, which is V was 100 over root 2 and angle 20 multiplied by I conjugate. So the conjugate of I will be, its angle will be positive. So 5 over root 2 and the angle is 40. So I can find S by using this equation or this equation, it doesn't matter. Now, you will multiply 100 times 5 divided by 2, so it will be 250. And its angle is 20 plus 40, which is 60. At the end, I can write this as 250 cosine 60 plus J 250 sine 60. If you try to calculate those, it will be 125 plus J 216.5 volt ampere. So you can use this equation or that equation, it doesn't matter. Am I fast? Should I slow down? Okay, I will solve it and I'll go back. Solve it with you again. Last thing, he asked me to find Z, which is equal to V over I. What's V? Actually, V was equal to 100 over root 2 and angle 20. What is I? It is 5 over root 2 and angle negative 40. So this guy will be equal to 100 over 5, which is 20, and square root with a square root. And the angle will be 20 minus 40. So at the end, this guy will be 20 angle 60. So the impedance will be 20 cosine 60 plus J20 sine 60. If you try to calculate Z, it's equal to 10 plus J 17.32 ohms. Could you please put your pen or pencil and focus with me a couple of minutes only? I'll repeat that again. Okay? Now, let me read the problem again with you. If V is equal to and I is equal to, can you please calculate the active reactive complex power and the impedance? The first step for solving such a problem is to find the root mean square voltage and the root mean square current. The root mean square voltage is 100 over root 2 and its angle is 20. The root mean square current it is equal to 5 over root 2 and the angle is negative 40. Who is not understanding that? Now, how to calculate P? Let me see the equation of P. P is equal to magnitude of V times magnitude of I arm S times cosine, the difference between the angles. What about Q? The same equation, but the only difference is using sine instead of cosine. So, if you would like to find P, P is equal to VI cosine. So what is V? V is this guy, 100 over root 2. What is I? I is 5 over root 2. Multiplied by cosine, the angle of the voltage, which is 20, minus the angle of the current, which is minus 40. This guy will give me angle 60. So I will multiply this by this times cosine 60, it is 125. Who is not understanding that part? Am I fast? Okay, good. Now, let us talk about Q. How to find the Q? It's similar to P. What is the difference? And instead of using cosine, I'm going to use sine. I'm going to repeat the same equation. But instead of cosine, I will put sine. So VI times sine. Then I will find sine this guy multiplied by 250. It gave me 216.5. Then he asked me about S. I know S is equal to P plus JQ, and this is what I did here. P plus JQ. I put P and I put Q. Or if you don't like to find S by using this equation, you can go back to the original equation, which is S equals VI conjugate, RMS. What is V? Actually, V is this guy. What's I conjugate? It will be similar to this, but I'm going to use a plus instead of minus. And this is what I did here. I said S is equal to VI conjugate.
Every time the angles sine split?
Yes. If you have real plus J imaginary, so it will be real minus J imaginary. Now, I would like to simplify this complex number. So I will multiply I will multiply magnitude by magnitude, which is 250, and I will add the angles. Then this guy is in polar formatting. I would like to convert it to rectangular formatting. So it will be 250 cosine 60 plus J 250 sine 60. This guy is giving me 125, and this guy is giving me 216.5, which is the same like this. So you can use either this equation or this equation, it doesn't matter. Last step, I asked you to calculate the impedance. I know that the impedance is equal to V over I. Am I right? So I will divide this V over this I. If you try to divide V over I, here, I will have that. This is V RMS over I RMS, or V max over I max. It doesn't matter. Because at the end, the root square will be cancelled. Are you seeing what I'm talking about, guys? So I can write this guy V RMS over I RMS, or V max over V max. It doesn't matter. Because it is ratio. So that's why I didn't write RMS. I left it general, as you like. So V is equal to that, and I is equal to that guy. So I will divide magnitude over magnitude. It will be 100 over 5 because root square will be cancelled. It will be 20. And for division, I'm subtracting the angles. So 20 minus 40, it will be 60. Then I will write this in rectangular formatting, 20 cosine plus J 20 sine. I got this number and this number. I can ask you more in the final exam. Based on Z that you got, are you expecting you have inductor or capacitor? Since this sign is positive, you are talking about inductor. Am I right? If you would like to be smarter than me and say, no, I have inductor and capacitor and they are connected in series, but the inductance effect is higher than the capacitance effect, which means XL is greater than XC because at the end, X total is equal to XL minus XC. Are you seeing what I'm talking about, guys? Or you can say it is inductor, that's okay, based on that sign. So if this sign is negative, I can say it is capacitor. Do you have any question for that problem? Okay, this is the end, and I'll see you on Friday to talk about the assignment, and if you have any question. Thank you.